One thing students quickly learn about me when we're solving equations is that the process of how they solve the equation is actually more important than the answer at times. So this video is going to teach you the process. First off, it's important to remember that an equation is just a balance, two expressions that equal each other. So if I have 2 plus 3 here, then I should have over here something that also equals 5. This would be my equal sign. So what can I do to this equation and still keep it balanced? Well, I could add something to it, such as a 4. But if I add 4 to one side, you can imagine a balance scale. I now have, what is that, 9. So I would have to add 4 to this side also to keep it balanced. So basically, if you add a number to one side of an equation, you have to add the exact same number to the other side to keep it balanced. That's part of the process. All right, now let's get rid of this. What about subtraction? Does subtraction work the same way? Well, sure. If I have 5, then I'll subtract 4. That would give me 1 on that side. Well, I'd have to subtract 4 on this side so that that side is a 1. What about multiplication and division? Well, here we go. I'm actually going to start on this side now. Let's say I say 3 times 5. What is 3 times 5? That's 15. So I'm going to put 15 over here. So this other side has to be 15 also. Well, if I do 3 times here, if you're using order of operations, that would be 3 times 2, which is 8, plus 3, which is 11. Well, that can't work. That's by design. It shouldn't work that way. Now, when you're multiplying, you have to multiply the entire side. So you think about that distributive property. And since I already know that 2 plus 3 is 5, I'll get that first times 3. There's my 15. Now both sides are equal. Okay, so let's end with division here, and I've got some even numbers here. If I divide 6 by 2, what am I going to get? 3. Now, if I come over here, can I just divide this by 2? Well, what's 2 divided by 2? 1 plus 4, 5. That's not going to work. No, I have to divide the entire side by 2. And so then 2 plus 4, I'd have to do the top first is 6. 6 divided by 2, there's your 3. The whole goal of solving an equation is to get the variable all by itself so that we can see what it equals. And so we're always trying to get rid of the things beside it. Now, when I get rid of that 5, I can't just say a minus 4 because I would still have 1 on that side. So what gets rid of a positive 5? A negative 5 or a minus 5. You can look at negatives and minus the same way. But remember, whatever I do to one side of the equation, I must do to the other side. These two right here, I'm going to make a big circle, they actually become 0. And what is x plus 0? Well, just x, and then equals 5. And I know what you're thinking. You're thinking, I can do that in my head, and I hope you can, actually, to be honest. But this proves that we are keeping an equation balanced. So you're actually doing a proof, and that's what I want to see. What I just did, the red arrow, that is my process. And I expect to see that on the simple problems so that when you get to the really big, ugly ones, you can do it because you've done it on the simple problems. All right, let's look at the next one. And again, the whole goal is to get x by itself. And in this case, the x is on the right-hand side. So let's see who's with x. The negative 3. Well, what's the opposite of a negative 3? A positive 3. So again, I'm going to do it this side. Those two are going to basically cancel each other out. But whatever I do to one side, I must do to the other. And so 8 plus 3 is 11. 11 equals x, and I am done. Once again, I cannot stress this enough. This is the process that I want to see. Do this by yourself, then come back. Okay, what'd you do? We have to get x by itself. Who's bothering x? The negative 5. What's the opposite of negative 5? What will make negative 5 turn into a 0? Well, it's opposite, positive 5. Is that what you did? So I'll put positive 5 here, positive 5 here. These are just going to become 0. They're going to cancel out. I'm going to have an x equals. Now, I want you to always treat these as the addition of positive and negative numbers. So what are the addition rules with negative 11 and positive 5? Well, subtract, and I get a 6, and I had more negatives, so negative 6 is my answer. Again, Don't forget the process. I have to see the process. What's the 5 doing to the D? Well, if you said multiplication, you are correct. Well, what undoes multiplication? What's multiplication's opposite? Division. So watch this, and I'm going to show you why this works. I'm going to put a 5 here, and of course, whatever I do to one side, I must do to the other side. And what is 5 divided by 5? 1. Not a 0, a 1, which is important, because what's 1 times D? D. And that's, I need him by himself, and there we go. And then equals 6. Here we go. This is the process. Please, 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 please do not do this. That's the old-fashioned division sign. We're going to use the fraction bar to show our division. Okay, who's bothering x? The -2. What's it doing to the x? Dividing. What's the opposite? What's going to help us get rid of that division? Multiplication. Now, I want you to put it up here. I'm going to put little parentheses around it here because if I put dots or x's, it might get confused. And then here. And the reason I want it up in the numerator is because that's the only way that I can get a -2 divided by a -2 and cancel each other out. If you put that guy down into the denominator, then I got an x over a 4, and that's a mess. So always keep that in the numerator. All right, x is by itself because 1 times x is x equals -10. And again, everything you see up here is part of the, what is it? The process. Finally, we need to talk about how to get rid of a fraction. Well, off the top of your head, do you know what number I can multiply times 2/3 so that I get a 1? So that I have 1 times x? Well, just it's flip. It's reciprocal. 3 over 2. All right, and let's talk about this. What is 3 times 2? 6. And then on the bottom, 2 times 3, 6. What's 6 divided by 6? 1. So they actually cancel each other out. But remember, I got to do it over here to this one also. And then I can just put this over here. And I have an x equals 8 times 3 is 24 all over 2. So let's simplify that to a 12. And again, my process is showing the 3/2 multiplying times both sides. All right, that's it. Now, go have some fun.